welcome to today's Spring Knowledge Transfer Showcase, where we will be finding out more about a partnership between PTC and Southern Water, who have been working together to improve network visibility, reduce risk, and build trusted data foundations for AI in wastewater monitoring across Southern Water's wastewater network. So just to summarise, we are here to help you deliver against Ofwat's expectations for best practice knowledge sharing across the sector. And we're supporting delivery of the Water Innovation Strategy 2050 through our knowledge sharing service, which supports the transfer of learnings from an innovation project to the wider sector. And we're aiming to create project legacy in order to help innovators to identify and adopt the right solutions at a greater pace. We actually did partner with Ofwat, the economic regulator for England and Wales, a couple of years ago to build a view of what best practice knowledge sharing looked like. And we worked with senior leaders across all the water companies, academia and suppliers to create this vision. So the 6 principles are to learn from what already exists before committing to innovation projects, which is why we're aiming to create this project legacy with showcases like today. Target innovation insights to the right audience to meet our objectives. So hopefully we have the right people on the call today to really take these learnings away with them and push the solution to their organisation. Insights are regularly shared through multiple channels from day one of the project. Sector knowledge is open and centralised via the Spring platform, and insights from both innovation successes and failures are shared, and that people are empowered to not only receive the lessons, but to actually embed them within their organisation as well. I'll quickly run through today's agenda before we launch into the session today. But before I do, I just want to point out that we will be launching a couple of different polls today just to gain audience feedback on the discussion material of the showcase. And then at the very end of the showcase, we'll be launching our regular spring feedback poll for the event itself. And this poll is a really impactful way that you can help us make sure that these events are providing that value to you, your organisation and the wider sector, and that these showcases are indeed supporting the faster paced adoption of solutions that we're setting out to support. If you can make sure to answer that poll when you do see that come through, that would be really, really helpful to us. Thank you. Also, we'll be having a live Q&A at the end of today's session, so make sure to pop your answers, your questions, in the chat for our presenters, and we'll answer those as we can in the final Q&A. So just to touch on the agenda, we're starting with an intro from Southern Water, some context setting behind the project, a technical overview, the implementation roadmaps and the steps involved in the project, return on investment, and then after the break, we'll come back to a deeper dive into those lessons learned and a live Q&A, as I say. And our speakers today will be Head of Operational Technology Platforms at Southern Water, Andrew Oliver, Utilities Lead at PTC, James Radcliffe, and Strategic Account Executive PTC, Glyn Rogers. So without further ado, I will hand over to you, Andrew.
Thank you. Okay. So Southern Water, I'm guessing a lot of you will know, we cover waste and water services in England for the 3 counties, Kent, Sussex and Hampshire, and including the Isle of Wight. We've got around 4 million customers, and the split is 4 million waste and then 1 million for clean water. In terms of my role and my team, we look after all of the technology platforms that manage data ingress into the business, and then that data goes on to be used for various operational and analytical purposes. We have in the region of 400,000 signals coming in from the assets across the estate. That ranges from the traditional telemetry systems that water companies have been using for decades, SCADA, and more recently, which is what we're here to talk about, the IoT estates. So we've got around 8,000 assets in the more traditional outstation format, and then the sewer level monitors that we've been working on over the last five or 6 years. We've got close to 37,000 of those. So a very different scale. The challenges that we had in moving from around 8,000 to around 40,000 devices was in mostly in dealing with comms issues and data issues, and that's where we've got a lot from PTC. The solutions that we've got in place are helping us control pollutions, deliver clean water, manage the stock that we have of water across. Most of the water into the water comes from underground aquifers, so it's getting the data around where that water is, where we need it to be, and then on the wastewater side, making sure that we're delivering that data to the treatment works effectively without any pollutions. The big challenge that we had pushing these sewer level monitors in was scale. 30,000 devices in total now, more than 30,000 devices, was a big challenge for us from a team that was dealing with around 8,000 in the past. The comms has been a constant problem from all of the devices. These devices sit mostly under metal covers in the road or in private properties, and so obviously getting a signal out from that is a challenge. The second part to it was we built a relatively complex architecture. So the data comes in via the manufacturer of the device. So we don't deal with the comms from site. The data goes from the device to the manufacturer's platform, and then it's ingested from those platforms into an MQTT broker that we manage. And then from there, the data goes off to a third party for analytics and off to our ThingWorx platform so that we can see that we're getting the data we expect and that the quality is what we were looking for. Doing all of that in a secure fashion was obviously a challenge, but just over and above security, just keeping the thing working is a challenge. The observability of the whole platform, and the ThingWorx platform has been revolutionary, really, in terms of what we've got from our infrastructure. The system is at a macro level publisher subscriber architecture, so that the data is published by our partners and subscribed to by the analytics partners and subscribed to by ThingWorx. So that's the main architectural pattern across the whole of the infrastructure, and that again was a change from the traditional telemetry used in water companies, where the outstations were polled by the system. So again, a transfer away from how we were operating for the last several decades to this new IoT way of working. What was our problem? In 2020, roughly 2020, it became clear to the business that we had to tackle the pollution problems. It was getting a lot of public recognition. It clearly had to be tackled. The two main sources of pollutions are the water treatment works and the sewer network. Our sewer network is in the region of 40,000 kilometers, so more or less the circumference of the Earth. So measuring the whole thing was clearly something we couldn't do off the bat. We got a chunk of work to do to figure out which bits of that 40,000 kilometers we wanted to monitor. We had budget, broadly speaking, for the first phase for around about 20,000 devices. So we had to figure out where we were going to put those 20,000 devices. So the strategy on phase one was we put them in where we'd seen pollutions in the past. So we mobilized two sets of contractors to help us get those devices in the ground. We had a team internally figuring out where we wanted them to go based on historic pollutions, and we rolled forward on that basis. The timescales were tight. We were given a difficult task to get these devices in the ground within the timescales that the senior management wanted them, and so things went in a bit of a rush. The quality of the installations in that first phase. So as that phase one started to complete, we almost immediately went into a remediation plan to sort out those devices that weren't providing the quality that we needed. So that was the first kind of two challenges. Then as that was rolling out the networks that we operate with, the cellular networks, had some disputes. So we started getting failures across the estate, between different protocols that we were using over different networks, and again, complexity of figuring out what was going wrong and where was a serious challenge. And the tooling that we got from ThingWorx really helped us to get to grips with that and identify what was causing the loss of data. And was it regional? Was it based on protocol? Was it based on the network provider? Was it based on the actual network provider rather than the mobile virtual network operator? So being able to analyze that data by those different layers, different dimensions, was really key to figuring out what was going on in this estate that had been rushed into the ground and wasn't performing how we wanted it to. As I said earlier, 20,000 devices in the ground, brand new devices that we hadn't any experience with, was a different order of magnitude to where we'd been operating in the past. So the ThingWorx platform provided us with that observability, as it says at the top there, and allowed us to contextualize the data and figure out where it was coming from. One of the issues that we had in one of the devices early on was all of these devices were new to market. We were learning fast as to which devices worked and how well they worked. One of the devices had got a tilt switch in it to identify if it had been tampered with once it was fitted. That tilt switch was getting triggered while the devices were being transported around our 3 counties, and the batteries were getting used before the devices were going in the ground. And contextualization of the data from the devices mixed in with the location information that we get from the networks allowed us to see that these devices were sending us information in transit and not from when they were installed, and that was, again, really useful. The whole system, with ThingWorx in the platform, has allowed us to do what we did. Without this tooling that we had, we would have been relying on spreadsheets, and with the best will in the world, I don't think that would have worked.
I just want to, before I kind of explain a little bit about who PTC are, I just wanted to kind of go through a couple of key enablers that we're seeing around digital transformation in the water industry. So what this kind of really comes down to is, and looking at some of that word cloud, is how you enable transformation across a water utility. So it's not just in one area, but it's end to end across the organization. So at the core of that is connecting the asset life cycle from planning and AMP programs right through to operations, maintenance, and optimization. And that's where that true visibility comes from. But visibility on its own isn't enough. So even with platforms, and point solutions out there, which a number of the utilities are utilizing, they're doing a great job of detecting events and providing insight. But the challenge that we still see is what happens next. So teams still have to interpret multiple systems, whether that be SCADA, GIS, EAM, IoT, you name it, and they're all operating in silos. So bringing that together into a single connected data layer is what actually enables that real-time decision making. So the third piece is making sure that this is grounded into a kind of water specific challenge. So things like asset criticality, regulatory performances, and that this isn't just about the technology. So it's about solving the problems that matter day to day. And that's closely linked to that is everything is now aligning to outcomes. So whether that's through Ofwat targets or environmental compliance or resilience commitments, because ultimately this isn't about deploying more systems. It's about reducing, in Southern's case, leakage, improving asset performance, and delivering a better service to customers. And none of that happens in isolation. It requires connecting that kind of full ecosystem. So when you bring these elements together, that's when you move from disconnected systems to truly connected data-driven, evidence-led operations. So I'll keep this bit brief, because what matters for today is not who is PTC, but what we enable. But we help connect operational data, bring asset context to it, and enable teams to act on it with confidence and evidence. And we've been doing this for a long time with a very large product portfolio across a multitude of different industries. So PTC is quite synonymous in the manufacturing domain. I think my American colleagues would say 1 in 3 manufacturing companies utilize PTC software, but fundamentally we've been doing this for a long time. So what is PTC within the water industry? So PTC sits across 4 key areas. So that's connecting data, monitoring operations, managing the assets, and enabling the governance and the compliance. And together that supports more connected and confident operations. So Andrew's explained some of the challenges that Southern had, but I think it's a far wider sector issue as well. What we're seeing now, the sector really has invested heavily in visibility over the last decade. So there's more sensors, there's more telemetry, there's more dashboards, and in many cases that's worked. But what we're seeing now is that there's a kind of shift in the problem. And it's no longer do we have the data, it's do we actually trust the data enough to act on it? And because increasingly, especially now with the regulatory pressures, you don't just need to know that something happened. You need to be able to prove where it happened, what caused it, what action was taken, and what the outcome was. And that's the move from visibility to confidence. And that's where context becomes critical. Now, increasingly, that kind of prove stage is just as important as the action itself. And that's where regulatory reporting, audit, learning, improvement, that's where they all sit, right? So it's not about those dashboards anymore. It's about creating that kind of full operating model from signal to evidence. And that's something that we've been working with Southern on now for a number of years. So what you're kind of seeing here is how we help connect that operational world. So within Southern Water, there's a number of different products within our portfolio then that they're utilizing. You can kind of see some of them on this page here, but that in that kind of asset world, service world, governance world, this is what creates a digital thread. So in Southern Water's case, you'll hear now a lot more about Asset 360 and ThingWorx, which Andrew spoke a lot about specifically. But the broader point is that PTC helps create that digital foundation that allows water companies to make those better decisions and act faster and build that confidence out. So if we're looking at ThingWorx plays the role of connecting and surfacing operational data across the network. So that's the kind of the sense. Asset 360 helps you understand, and then ServiceMax can help you act on that. So it kind of brings together the telemetry sensors and all the different systems to give you that real-time view of what's happening. But more importantly, it doesn't just surface the data, it starts to structure and standardize it. So instead of the raw signals coming in from multiple sources, you begin to get more of that consistent operational picture. So Andrew, I might just ask you a question here too, because I'm doing a lot of talking, but you mentioned a lot about ThingWorx and obviously and Asset 360. How's that changed things on the ground for you now?
ThingWorx allows us to identify where we've got data missing, and it helps us to figure out where we've got data quality issues. One of the massive issues with sewer level monitoring is benching. So the chambers will flood and the device gets moved. It's got a fairly narrow beam of radar that it's trying to look at a relatively narrow channel in the bottom of a chamber. If it moves a little bit, then it starts measuring the concrete and not measuring the effluent. We can spot that with ThingWorx. Asset 360 is helping us identify two big metrics that I was really looking for. First was the mean time to recovery. When we visit a site, we typically, because these devices are sealed for environmental protection, the remediation of a device is pull it out and put a new one in. So the device metadata then changes, and our third party who does the analytics has to relearn from the new device what they expect to see in that particular stretch of the sewer network. So that was taking us up to 6 weeks for a device swap, which just is really problematic in terms of our data availability. So and ThingWorx, 360 in particular, is helping us get to grips with the different elements of that 6 weeks across those different dimensions. So the time it takes us to get to site, the time it takes us to actually sort the device out, and the time it takes us to correct all of the metadata through all of the different platforms. And that's helping us get from, like I say, 6 weeks failure recovery to a few days. That really impacts on our availability, which is what we measured on.
Right. Okay. Well, we'll touch on that later on in the session when we're going through the metrics and so forth. But no, cheers for that. So I think fundamentally what we're seeing here is that combination of ThingWorx and Asset 360 becomes really important, because it's not just about bringing the data together. It's about making sure that data can actually be trusted. So if you look at ThingWorx, which is constantly ingesting and standardizing the operational signals, but then what Asset 360 is doing is where that data is validated, contextualized, and then governed against the asset. So you move from a model where data is, excuse the pun, just flowing, so to one where it's being checked, structured, and anchored to something which is real. So the asset, its location, its condition, and its history, right? That effectively creates that layer of control around the data. So instead of teams questioning, is this right? What does it relate to, or can I actually trust it? You have a system that is continually enforcing the consistency and the context and the quality of it. And that's where, Andrew's team has been seeing a lot of success around that. And that's what allows you to move from visibility to real operational confidence. So alongside that capability, things like Codebeamer support the govern change. So it's how do you ensure that traceability and alignment across the engineering and operational process. So I'm not going to go into too much detail here, but because it becomes really important when you think about it, how decisions are made, and more importantly, how they're justified. Because one of the challenges in water isn't just responding to events. It's being able to demonstrate why a decision was taken. So, what was it based on, and how it links back to whether that be policy or risk or even regulatory requirements. And that's where the governance layer comes into effect. So Codebeamer essentially provides that structured way to manage change. So whether that's the asset strategy decisions, or whether it's the engineering changes or operational policy. So instead of the decisions sitting in emails or spreadsheets or disconnected systems, which is a lot of the time where they sit, you have a controlled, traceable record of what's changed, why it changed, and who made that decision. And when you connect that back then to Asset 360 and the operational data, you start to close that loop. So from a signal to decision to action, and then ultimately to evidence. And that's what turns the operational improvement into something that's not just efficient, but what's really important now for a lot of the execs within the water industry is that it's defensible. So this slide really brings the operating model together. So at the front end, you've got the operational signals. So whether that's, as Andrew mentioned, the sensor, the telemetry, the SCADA, whatever it may be, that's where kind of ThingWorx sits, as I mentioned, but it's connecting and surfacing that data in the real time. And from there, then you move into the asset context. So understanding what that signal actually relates to. So which asset is it? Where is it? What's the history behind it? So, and I know I'm kind of repeating myself a little bit here, but that's where Asset 360 is really creating that consistent, trusted view of the asset. And then the next action or step per se is this is where the service comes into play. So what are the maintenance crews, the engineers, the interventions in the field? So again, linking that back into into ServiceMax and enabling that execution layer. And then finally, then you've got governance and evidence. So making sure everything is traceable, everything's reportable and auditable. So it isn't just about the system, it's about that connected operating model that takes you all the way from the signal, all the way through to decision, through to evidence. So what is Asset 360? So having introduced the idea of that evidence-led operations, the obvious question is what's the model? How does it actually go in? So fundamentally, Asset 360 isn't another dashboard. It's not trying to replace the system Southern had already. Instead, it sits between those systems. So between the telemetry, the GIS, the maintenance, the service, and the decision teams needed to make that, right? And that's important because operational data on its own doesn't always create confidence. So that sensor might trigger, an alarm might fire up or whatever it is, but until you understand what asset that relates to, where it sits and what's happened before, fundamentally it's just a signal. So what Asset 360 is turning that signal into something meaningful. So it's creating that consistent, trusted, asset-centric view. So every event is anchored to the asset for its context and its history. And that's what allows teams then to move from simply seeing events to actually knowing what to do about them. And critically, it ensures then that the data is not just connected, but consistent, right? And it's trusted across the organization. So in simple terms, Asset 360 is the layer that makes that operational data usable, right? Trusted and really actionable around that. So what Asset 360 has been doing within Southern is creating that consistent foundation across the data, right? So it's mapping everything back to that common asset model. It's validating it. It's giving you that device health and obviously introduces that repeatability. So instead of solving one use case at a time, you create that foundation that can support many. So you can kind of see on the slide here, it's quite a busy slide, but all the potential different use cases that it can interact with and make change on. So if you haven't picked it up, that it's not about solving that one specific problem. It's about really kind of taking what works and repeating it. So what's the same data model? What's the same decision process? What's the same operating approach? So whether that be in Andrew's case, the sewer monitoring solution, but it's also scalable, or a scalable operating model for the entire water network. So you can kind of see on the right-hand side there other kind of uses cases which we're looking at within Southern and other kind of utilities around the globe. So this slide really shows that journey from end to end. So you start with that kind of raw signal. The data's coming in from your IoT sensors or the events of the telemetry, and then you move it into that context. So it's understanding what that signal actually relates to. So the asset, the kind of location, the business impact, and then from there, then you get the intelligence. So it's then where those patterns start to emerge. So the insight which is generated, or the risk or the priority becomes really clear, and that's then what drives the decision. So it's triggering the right action through the service flows back into the right areas of the business. So I'm just going to, because I'm doing a lot of talking here, I'm just going to run a little video, but everything we've talked about so far creates that foundation. So what this next piece shows is how that foundation starts to unlock broader asset and service optimization. So things like predictive maintenance, asset health scoring and planning, right? They're all built on the same connected data and asset context. So again, we won't go into detail on it today, but I'll just play a short video to bring that to life. There's no sound, so I'll let you play it through. I've done it on a fishing reel, but just keep an eye on how it connects asset insight through to action. So what that shows is once you've the trusted asset foundation in place, you can start to layer in the optimization. So whether that's predictive planning or service efficiency. But it still comes back to the same thing, right? Trusted data, connected assets, and then that kind of repeatable process. Okay. So let's kind of just build this up a little bit, because AI builds on the same operator model, right? So it enhances it, and it's helping with things like prediction, risk prioritization, and decision support. But fundamentally, if your data is not clean, there's a real challenge in the first place, right? And that's again back to that kind of foundation layer that we're talking about. But it doesn't work in isolation. It still relies on having that trusted data layer. So you need that clear asset context and a really consistent operating model underneath. So without that, purely the AI is just going to add noise. So that's something which we've been working on for a year or two now, particularly with the types of industries that we're working in, which are very critical to everyday life. So this is where AI starts to unlock real value, because from a prediction through to decision support piece. So if you look, what kind of the difference with PTC is that AI isn't bolted on, it's kind of built it on as a connected operating model. So it's more with that trusted data and asset context and the kind of integrated workflows underneath it. So instead of having the isolated analytics, you get the AI that's connected to the asset and it's linked to the process to drive the real action. And that's why it scales and why it delivers the outcome. So it's not just insight, it's what you can actually do in and around that. So I'm going to pass it over to Glyn now, because I think you've heard my voice enough, but we'll let Glyn explain a little bit more about Asset 360.
Thank you, James. So I want to touch on a little bit about the implementation journey that we went through with Southern Water. So it really was based on a crawl, walk, run approach. So we didn't want to boil the ocean. We wanted to make sure that we started small with an MVP, and we really focused on a specific area, which, you know, as Andrew touched on earlier, was just within the sewer level monitoring devices. And we targeted 3 initial use cases, right, just to prove the value of what we were trying to achieve together. And that was essentially providing a single source of asset truth and device truth, having that visibility into the device data from a unified view, being able to deep dive into that data to understand, you know, things like asset and device attrition rates and so on and so forth. And then being able to analyze metadata and site information, right, to identify critical assets. Where are our risks across the network, and where can we provide some operational insights to support the team? And then the next step was really about establishing those proof points. So, you know, demonstrating that the solution achieved those 3 use cases that I mentioned, but then looking into what insights that those use cases derive, right? I touched on one earlier about the attrition rates of devices, right? And that can help inform supplier supply chain decisions, right? Which devices work best under certain conditions, and based on those conditions, what devices should Southern Water procure to support the network. But James was touching on earlier about data validation, right? So understanding and verifying the data that's coming out of the signals. I think Andrew gave a great example earlier about where data wasn't valid when sensors were being moved around across the network, for example. And so having that sort of data validation point was really critical in terms of establishing a proof point that the system was working based on the use cases that were identified. Providing those operational insights, right? So James touched on that earlier about, what is the status of ongoing work? What was the history of work that's going to be pulled from, maybe an EAM system, right? Or a service management system, so that you can get a granular view of the context of the asset, when it was installed, everything that's happened against the asset across its history, so that you can have that operational insight. If it was worked on by a subcontractor, which subcontractor was working on it, installed it. And that can give you insights as to, do we have a device problem or do we have a people process problem, right? As the subcontractor that installed this got the relative amount of training to be able to install this correctly under the specific conditions of the location, for example. But all of this feeding into supporting Southern Water to identify regulatory risk, not just based on geographical areas of where the risk could be identified, but also prioritizing those geographical areas, right? So if there's lack of connectivity near a chalk stream, for example, where regulatory fines are considerably more significant, how can we flag that in the system to provide Southern Water with where their greatest risks are, and how they can help solve that moving forward? And obviously, over time, we deepen those use cases and understand what next, right? What other use cases? And that leads us into the expansion of the usage as time went on. And that is now looking at, so, in May, we've expanded the solution to go across all of the SLM devices that are across the network now. So driving complete network visibility. And now assets outside of wastewater are also being considered across the water space, for example, the clean water space. And new use cases are being identified all the time. How can we push data to subcontractors to provide them with more information in order to, based on the site or the device, to support them in them executing the work to maximize their productivity and efficiency, which will have a knock-on effect on device availability and the overall visibility of the network. And then, so I wanted to just drill into some of the specific use cases that we identified initially. So those 3 core use cases that we targeted. The first one was establishing a single source of truth for device data. So we've included some screenshots here on the right-hand side, and you can see here that you've got how this data rolls up to an executive summary view, right? So that you can have view of SLM and EDM data by region, and then you can start to understand how the data is trending, right? And obviously, this is all post that data validation and verification that we talked about earlier on. And again, as mentioned, that's going to help those supply chain decisions, right? And also enable operational focus. Do we have more devices that are running close to the end of their battery life, for example, in a specific catchment area, and therefore we need to be prescriptive with our subcontractors to go and focus and prioritize that work. Having a complete overview of the RAG status, or the red, amber, green status of devices, and that will help you to identify the areas of risk and also advise on those operational efforts that need to be made as well. And having that unified view on overall asset availability that you can see there along the bottom, right? The total number of assets, within a specific catchment area, and then being able to align that back to the specific operational team objectives, right? And enable the compliance to ensure that device connectivity and availability is at the level that is required. And the next step was diving deep into that device data, right? And that essentially was providing not just the overview of the overall network availability, but being able to deep dive into specific device by manufacturer or by sub-region, for example, to provide that overview. As James and Andrew mentioned earlier, having the alarms to alert on device failure and having that trigger alerts within the system. Now, those alerts can be used to automate action, as James mentioned earlier as well, right? Do we need to automatically generate a work order, push that to our EAM system based on an alert failure? And that's going to help you to maximize connection uptime and enables fast action to mitigate regulatory risk. And also the layering over of the operational insight, that contextual information I mentioned earlier, right? Who was the last person to work on this asset? Were they a subcontractor or was it internal? What is some of the context that drive that? And that's going to help you to understand why assets fail. Is it because of the device data that you're seeing from the telemetry data? Or is it from operational data that you're seeing, as I mentioned earlier, about training insights that we can provide to subcontractors, for example? And that's going to enable you to put forward prevention strategies, right? Training for partners, supply chain decisions that essentially are going to have that knock-on effect of maximizing the device availability to achieve the objectives of Southern Water. And then having that visibility into trends across the device types, right? So is it a situation where a specific device type, without naming a manufacturer, their devices work better and have longer battery life when they are in low connectivity areas than their competition, for example? If you've got an area of the network that as Andrew touched on earlier, about private residences, etc., where you don't have a strong connectivity, which devices work under those conditions in the best way? And that can help inform those decisions of, okay, we will deploy this device type in these areas where we know we have less connectivity, but actually maybe it's a different device type when there's great connectivity that has a longer lasting life and maximizes the availability. So really important to understand the trends in the data there. And then being able to analyze metadata, the site information, and ultimately identify critical assets, right? So having an overview of all the connected sites and the locating those areas of risk that I talked about earlier, like, for example, near chalk streams and so on and so forth. And that's going to help you to prioritize those operational efforts, whether that's internally or through the subcontractor network. And then drilling down into specific site information, understanding that service history and providing that context that we talked about, but having those real-time status updates from the field as well, right? That the work order is currently in progress or it's at this stage in the process, to give you visibility into resolution times and resolution steps that are being taken across the asset management activities. And then being able to run analytics based on mean time between failures across sites to help understand, again, why are specific sites having more downtime than others, for example, so that you can work on those prevention strategies that we talked about earlier. And being able to review the device metadata in a single UI, right? So all of this data is pulled all over the place, and a lot of the time for different organizations, this is spread across multiple different systems, right? So ingesting this into a single system with a single UI to have traceability of all the connected devices, and viewing those correlated trends, for example, temperature, power, depth, for example, that you can see right on the right-hand side in the graphics that are shown. So this is, essentially some of the sort of key elements, but ultimately it drills down to identifying those critical assets, right? And those critical assets are defined as sites and devices that have less than 90% connectivity, right? And that's going to help you to understand where are those critical assets, how do we prioritize those critical assets based on their location, based on their prioritization, and then how do we use that to mitigate our overall regulatory risk, minimize leakage and pollution across the network. So those were the kind of core 3 use cases that we focused on, and some of the areas of how the system drives those outcomes that we talked about. But I'll hand over to Andrew to talk a little bit more about some of the value that was derived from using the system.
The big one is obviously reducing fines against pollutions. So when we started off on the program in 2020, there were a significant number of pollutions. It's been across the media quite a lot. Southern Water have been highlighted as being a villain of the piece, or however you'd want to put it. So the regulatory regime has become stricter, and the two areas, as I said earlier, the two areas where we had pollution issues were the treatment works and the foul sewer network. So our team were asked to help with identifying blockages in the sewer network before it ended up being a pollution. And in order to do that, there were new devices around at the time, the sewer level monitors that we were using, and also new organisations were coming together who were able to analyse that data and provide us with the insights we needed to clean the sewers in the appropriate areas. In the last 5 years, the regulatory regime has changed a little. So what used to be categorised as Cat 4 pollutions, which were mostly pollutions where there was no consequence and subsequently no fine, that a lot of them have been moved into Cat 3, where there is pretty much always a fine, and those pollutions are deemed to be more serious. So we've had a levelling up of how much any issues that are caused by the sewer network would cost Southern Water, and at the same time, we've been able to reduce our pollutions and mitigate that before it actually hit us. So that's been a fantastic improvement. In order to keep all of this kit working, is really the service execution efficiency, the one in the middle in those the second row there. That's been the piece that I've been focused on for the last 6 to 8 months, just getting those figures. The availability of the data that we use in order to make to get these insights is monitored constantly. My team are looking at it on a daily basis, and we report to the execs on a weekly basis. And then there's a report pack goes up once a month as well with finer grain detail. That piece has taken what was a manual job, figuring out what the availability was across the estate, to completely automated, and those reports just are made available to my team, who report it up the chain. And as Glyn was saying, we've already expanded from just looking at the sewer level monitoring into EDMs, and anybody in the UK water industry will have seen how rigorous Ofwat are in making sure that we comply with EDM reporting. And again, we've leveraged ThingWorx to get complete automation of our EDM availability. The other area where I've had to focus a lot of my attention has been around the cost of the contracts. These devices are in a particularly unpleasant environment. Most of the outstations that we have are in nice cabinets at the side of whatever that is that they're measuring. These sewer level monitors are literally in the sewer. So the data availability from these devices is quite a bit lower than traditionally we would expect from an outstation. On our outstation estate, we run at sort of 99.8% availability on the data. On the sewer level monitors, our SLA at the moment is 90%, and we've been consistently at 92% for the last 6 months. So we've really been able to deal with keeping the availability where the business need it, without exceeding my budget on the cost of the contractors. And the contractors are based across our 3 counties. We've split the county. We've split the region into 2 areas, and we've got one set of contractors working in one area and one set in another. And down the middle, there's a little bit of crossover. Keeping those guys on it, making sure that they are as efficient as we can get them, keeping the abort rates low, has been a challenge. And again, the data that we've had coming back out of ThingWorx and Asset 360 has helped us keep on top of those contractors and make sure that we get the performance that we need from them, that they are making use of the time effectively, because that's what it all comes down to. big picture really is the cut in the fines. That everything else pales into insignificance really next to the fines. They are an order of magnitude more than it costs us to keep the contractors, which is the second biggest cost. So that's as Glenn said, keeping the pollutions down is obviously massively important for everybody, and the way that that's enforced on us is with the fines. So we're really getting on top of that and getting things to where Ofwat and the EA want it, and ultimately that'll help us with our public perception.
So what we wanted to focus on now was some of the lessons learned from the project, and kind of, obviously it was something completely new and fresh for Southern Water, and it will be for many of the audience. It'd be great to understand what you saw as some of the key lessons learned as you embarked on the project, as it was a new experience for Southern Water.
So many. Where do we start on that one? So the obvious one was the pace that we went at. The initial rollout was incredibly fast. We brought in more contractors who had never touched the devices before, who were familiar with working in sewers, but they weren't familiar with the technology. We got a load of very poor installations that had to be remediated. So that we learned that one very quickly as well. That the contractors who were failing were in and out within a couple of months. So they caused a lot of damage while they were with us, but they didn't stay with us for long. Then the second one, which was really interesting, was and this took us a bit longer to figure out, was that historic pollutions weren't really a good indicator of where we were going to get pollutions in the future. So the phase 2 that we followed on with, so the initial 20,000 devices went in based on historic pollutions. The follow-up 8,000 that we installed, and this goes to a couple of the questions that we've been given as well. The follow-up ones were put where if there was a pollution, it would be more impactful. We've got in Southern Water's region, we've got chalk streams which are of global significance, and we've got a bunch of SSSI, sites of special scientific interest, and pollutions in the proximity to those areas are just not acceptable. So we had a tier 1 level of devices that went in phase 2, which were near chalk streams and near SSSIs, and then the tier 2 were around sensitive watercourses, and tier 3 were around other watercourses, and then tier 4 was everything else. So we focused on phase 2 in making sure that every manhole that was within, I'm going by memory here, I think it was within 10 meters of a SSSI or a chalk stream, or anywhere that was of particular significance, every single manhole in those lengths of sewer had a sewer level monitor installed. In the next tier down, it was every other one, and in the next tier down, it was 1 in 4, and then in tier 4, they were much more random. They were placed where more or less on the rules that we'd had originally, where we'd had historic pollutions. So that was a real key learning, and it took our data team a relatively long amount of time to figure out the rules and then apply it to the GIS information to work out which manholes we wanted these devices to go in. But that's been a really good transformation. We haven't had any pollutions anywhere near the SSSIs or the chalk stream since this change was made. So it's been fantastic. The other one, the next learning was, but this wasn't really a learning from this one, but it was apparent in this particular project that every time you add in another organisation, your level of complexity goes up by an order of magnitude. It doesn't double. And so, yes. And we've got multiple organisations in this. Obviously, there's Southern Water in the middle of it. We've got PTC, who didn't increase the complexity by any means, obviously. And then we've got 3 device manufacturers with 3 different platforms that we use in proper production systems, and then we've got another 2 that we integrated to do evaluations of their devices. So 5 different manufacturers coming into the system, and then we've got our analytics partner, Storm Harvester, providing the layer of insights over the top and providing those insights back to us. So integrating all of those different organisations into the system has been interesting. almost all of the data comes in by MQTT, but not all of the providers could deliver the data to us via MQTT. So we've got some API integration as well. We're working that out because MQTT is our preferred way of getting this data. But for expedience, we went with APIs, and the level of visibility we get from an API infrastructure, which is, that's been the traditional implementation for any kind of integration for probably the last decade. The visibility of what's going on in that infrastructure is not as good as with MQTT. We get better insights where we've got data streaming rather than having to poll for it.
That's great, and I think it sounds like there's a lot going on in terms of collecting the data, managing the data, the multiple different systems, managing the subcontractors in order to deliver and run the network. But what was obviously in those two parts, really, the sort of data aspect and in the actual management and the operations around the network, what was it like before all of this technology came in to sort of simplify these processes?
So the sewers were cleaned on a time basis. So particular lengths of sewer would be cleaned every month, every 6 months, every year, whatever we thought was needed for that length of sewer. And we've got 40,000 kilometers of sewer. So quite a lot of it still operates that way. Where we've got the technology in, we're now completely dependent, and rightly so, on the information that we get from those sewers rather than just cleaning them on a time basis.
And what were some of the decisions that, previously you wouldn't have been able to make? Obviously, if you're doing it, as you say, you're on a time basis, that's not going to help you to drive decision making. So what were kind of some of the decisions? We touched on some of them earlier in the presentation, but just to get a bit more insight into some of the decisions that you can now make that you weren't able to previously.
We know more about groundwater ingress now than we did before, so that's been interesting. In areas around Southampton, there's big wetlands, and Southern Water are providing the drainage for the areas around those wetlands. It's not what we're supposed to do, but because the sewers have got cracks in them, and things that we're now finding out, we're having to treat a lot of water that is basically just groundwater through our foul sewer network. So we've got programs now to look at whether it's going to be cost effective to line those and cut that groundwater ingress down. Some of the devices we've been using more recently have got temperature sensors in as well. So we don't just get the level, we get the temperature of the effluent, and that's been interesting. I don't know whether we'll use this, but there's a wildlife park in part of the estate, and we found out that they were cleaning out the rhino enclosure with hot water because we were picking up the heat of the sewers on a daily basis, and the amount of hot water that was coming down the sewer network was more than they got an abstraction license for in the first place. So there was a conversation with the wildlife park about how much water they were using.
Oh,
sorry, James, did you want to say something?
No, I just found that interesting.
No, it's great insights and things that obviously that you weren't able to have a view on before. Obviously, this is going to have a commercial impact technically with the wildlife park, but it's just interesting to see these different kind of use cases coming out, and there's more being created all the time, right? And I think just going back to the subcontractors, I know that when we initially spoke, Andrew, all those months ago about some of the challenges that you had in managing those subcontractors and the field work. Can you just give a bit more detail into what life was like working on the installation of these devices with the subcontractors before, and what some of the insights you've got now are to help you to make those decisions?
So we've had 4 different contractors in the estate working with us now, and so there's been a lot of learnings from one to another as to what best practice is. One of the contractors is really methodical around collecting photographs of the assets before they'll install anything, and which are invaluable when somebody goes back. Being able to use the information from GIS with ThingWorx has helped enormously in getting people to site, and these photographs are really improved that enormously. So we have the GIS information, the location of where the manhole is, and now we've got a set of photographs. And the best practice has been one from a distance, so that you get like a broad view of where it is, with all the trees and buildings and whatever around. So as somebody approaches it, they can see they're, broadly speaking, in the right area. And then one closer, and then one looking down in at the asset itself, so you can see how it was installed, ideally with serial numbers, so we can see from a photograph against the site visit which asset went in the ground, with another set of photos showing which hole it was in. We've got the foul sewer network is in proximity to the normal surface water drains, and we've had a few instances where SLM's sewer level monitors have gone into surface water drains. So the next contractor's gone along and gone to the right chamber, the one that's in the actual foul network, lifted the cover, and there's no monitor in there. But we've been getting data that looks right. It goes up when it rains, and it and all of that kind of thing. So then we've had a bit of work on to try and find where the device actually is and get it moved into the right chamber, and that's happened far more than you would like. And those photographs in particular have really helped across all of the 4 now contractors that we've used over time. Getting that consistency around those working practices has been really, really useful. And it's something simple, and kind of you wouldn't expect with the rest of the technology that we're using, that something as simple as a set of photographs each visit has made a dramatic difference.
Yeah, and you can totally understand that, driving that consistency is going to help you to drive value and efficiency and productivity, because obviously ultimately their efficiency and productivity equals your availability to some extent, right? Mm-hmm. So that's going to be really, really helpful in achieving your objectives. Yeah. One of the things
I kind of touched on it earlier. The abort rate is our measure of efficiency of the contractors, really. They take however long it takes them to get to site. If they then abort, that's a lot of time lost. And making sure they find the right manhole and they've got the right access. Again, the photos really help with that.
So that's the system helping you to sort of better enable the subcontractors in terms of locations and access, because obviously you talked about it before, some of these manholes are on private residences and in difficult to access areas where you might need specific permissions and so on and so forth, and having context of that as you go to site, or the subcontractor goes to site, is going to help you to maximize the access to them, right? And give you foresight to, okay, we're going to need the permission access to access and so on and so forth, which is going to help drive those outcomes. One of the things we talked about before we sort of embarked on the project was around the subcontractors and there being, because obviously, look, you're fitting thousands and thousands of devices at the same time as fitting and installing new devices. You've got ones that you've installed in phase 1 that are now starting to fail and run out of battery, for example, or move to other parts of the network because of poor installation. And this was creating what we talked about at the time as a kind of significant backlog in work of getting the new sensors installed and replacing the ones that needed replacing. What's been the impact on that backlog of work since the installation of Asset 360?
The metrics that we've got around mean time to failure and mean time to recovery have been transforming in how accurately I can size the teams, and the teams are relatively expensive. So getting numbers that we can all trust that help us right size how many contractors we've got on the ground running around the 3 counties has been the real value piece. That's where it's made its money.
So there's almost 2 elements to that then, isn't it? So you're helping the subcontractors become more productive and efficient, and that's having a knock-on effect, as we discussed with the last question, on those availability rates. But it's also helping you to make decisions on, well, if we make our subcontractors more productive, they can carry out more work in a day. And if they're carrying out more work in a day, then is there the need to have so many subcontractors as you reduce that abort rate, for example? So it's having that cost impact, but also a productivity and an availability impact.
Yeah, exactly. So I've been targeting 90% availability on the devices, and I've been flexing how many teams we've got on the ground to get that figure.
And what in terms of the actual devices themselves, right? What has this done in terms of actually protecting and managing? So we touched on the subcontractors, we touched on the data, but in terms of the actual devices that you're seeing out there, what kind of impact is this having on the physical asset base?
The devices have got a bunch of interesting characteristics that we've been able to pick apart and identify where we can either ignore strange artifacts in the data and just use the data regardless, or we've got to make a visit. So I kind of touched on it earlier, that if the chamber gets surcharged and the device moves, more often than not, it comes back and it's okay. But quite often it can be getting a radar reflection off step irons or somewhere else in the chamber. There's not a lot we can do about that other than a site visit. There are other things that we picked up where, with ThingWorx in particular, we can correlate the level of the battery, the radar power that's been used by the sensor itself, with the signal that we get back. And we get this thing called vampire's teeth in the data, which is this, every now and again, we get these two consecutive spikes and they're a set time apart and they look like vampire's teeth. So that's what the team have ended up calling them. And we know that we can just filter those out because the rest of the data around them is fine. And that seems to be an artifact based on specific battery performance and the radar power. And when the two things come in some specific way, then we get these two spikes. And now we've got enough data that we can just remove that little bit, and the rest of the data is fine, and we don't need to make a site visit.
Yeah. So otherwise, you might have thought there was a problem, and there might not necessarily have been. And obviously, that is also going to have the knock-on impact of the operations, because that's a site visit that, had you just have had the telemetry data and just had a view on that, you might have sent someone to site, which is obviously, we talked about the subcontractor and the efficiency around that earlier. So that has an interesting impact. But in terms of the devices, how is this kind of impacting the relationship that you've got with the suppliers? Because obviously you've got a view now on how the devices are performing in specific circumstances. I imagine that you've got some, real, golden nuggets, so to speak, to take back to the suppliers in terms of how the assets are performing under different conditions. And obviously that could provide them with the insights to make more enhanced products to further support the entire water industry. So how's that relationship changed, and how are you able to support those conversations based on the data?
The relationship is an interesting one. So the metrics that we're getting are quite wide in terms of mean time to failure. So the mean time to failure is a function of the device itself, its firmware, the location in terms of the cellular coverage, and that is much bigger than you'd like. But then also the device quality and the different manufacturers. It's now becoming apparent to us that the different manufacturers have got a different level. We have a different level of expectation against them for how long those devices are going to last in the ground. The worst performing ones we're having to visit more than once a year. The better ones are 5 years and higher. So we're having to project some of that from other data, but we've got the same devices doing different jobs across the waste and water estates. So we can reasonably expect them to behave in the sewer as they are doing elsewhere. So yeah, we're between 10 months and 50 months depending on the device. And that obviously we can then take that back to the manufacturer and say, 10 months we can't really cope with. The mean time to failure has got to be better than that, and we can't attribute it to the contractors installing it, because different contractors are getting the same results. The mean time to failure is now concretely, if that's a word, attributable to the device and not to the installation.
Yeah, exactly. So it's siphoning out the information to identify to you to say, okay, well, we've got these devices, and they potentially have this warranty period or this claim period, for example, and you can obviously go back to the manufacturer and say, look, you're not meeting your commitments to us as a customer, and we need more support in, and Obviously, that's going to help from a cost perspective, because obviously that warranty will be covered, but also help you in making those decisions, which I think is really important.
Yeah, and all the manufacturers have firmly stood behind their warranties. We haven't had any problem with that. But again, it allows them to address the issues that they've got.
Yeah, completes that sort of product life cycle, right? Of going back to them to make their, design considerations and so on and so forth to make better devices in the future. So we've touched on the data, we've touched on the operational side of things, we've touched on the devices themselves, and I kind of wanted to round up with what you in your own words said was the everything else pales in comparison to the regulation, right? And how important that is as the sort of centrifugal point of the whole project, essentially. And we all know that regulation in this space is tightening. But how has the use of ThingWorx and Asset 360 together sort of changed your ability to demonstrate control and provide evidence to the regulators to ultimately meet compliance standards?
The obvious example is on EDMs. So round about when the new Labour government took over, Ofwat were given the task of measuring our performance in reporting on the event duration monitors, which are sitting, for those who are not in the UK, they're sitting on all of our overflows. So anywhere where the network overflows under storm conditions, which it's designed to do, we have to report to Ofwat within an hour at the beginning of an event and within an hour at the end of an event. And those metrics are then used to rank different water companies against each other. And ultimately, if we don't report on it, there are fines. But if we spill when we're not supposed to, there are fines. So being able to report on that accurately is a combination of the devices in the ground plus our reporting technology. So all of that data in one way or another goes via ThingWorx right now. So the EDM data is collected by a combination of traditional outstations and more up-to-date data logging equipment. It goes into comes into our estate via a couple of different mechanisms. It's then surfaced within ThingWorx. The availability across all of those assets is calculated. And again, as I was saying earlier, it's reported on internally to my team every day, and it's reported on to management once a week. And then we have to report on that to Ofwat monthly and a bigger report annually. And all of that now comes out of ThingWorx. And prior to December last year, when we finalised that reporting, it was taking almost a month to create the monthly report. So it was just like a constant job for somebody. And now it just pops out of ThingWorx, and it's almost no effort. It's been a big transformation.
No, that's brilliant, and obviously it's great to hear as well that it's having. Obviously, you've got the kind of example we shared earlier about the chalk streams and the areas of risk, right, where there's the largest fines and highest categories of fines, but also interesting to you to relate it back to the indexes as well, right? We talked about during the initial phase of the project about CMEX and DMEX, which we know are kind of customer satisfaction surveys essentially, but obviously how that changes your potential ranking. And obviously, we need to get the data back and we need to go through a bit more of the project, but hopefully this has a real knock-on impact in your position in those CMEX and DMEX rankings.
Yeah, it'll be a massive leading indicator on CMEX. The public perception of the whole of the UK water industry across the UK is poor, to say the least, right now. Improving our pollution will have an impact on that. It hasn't yet, but it will do.
Yeah, no, it makes sense. And so I think we've got a really great overview here of you're ingesting data from multiple sources to give you contextual insight. You're then that's then enabling you to make better decisions, have better communication with, a feedback loop to your suppliers, better communication with your subcontractors to enable operational efficiencies in the field, which also has a knock-on effect on availability. And overall, that availability is going to provide you with the insight to achieve the regulations and stay within the compliance standards set by Ofwat. So that's a really great foundation that this is all given you. But where do you go next? Where's the plans for the future, and where do you see you taking this across Southern Water in the future?
So there's a really big program at the minute that's just kicking off around smart networks. The way we're operating with the sewer level monitoring, it kind of fits in with the strategy for smart networks, and it's informed the strategy for smart networks. Smart networks it's all about a smart water cycle. So we collect water from the environment, we treat it, we deliver it as clean drinking water to our customers. We collect the waste and we treat it, and we safely return it back to the environment. So that whole cycle, and we've got instrumentation right through the whole thing. So the next stages for smart networks is going to be the big one is going to be around leakage detection, and at the moment ThingWorx isn't touching on that very much. We're able to see some of the instrumentation, but there's a big program to roll out some more advanced leak noise correlating devices. So we'll be picking up the noise of the water passing through the mains, and we'll use the changes in that noise to determine when there's a new leak and where that leak might be. In order to do that, we'll be putting new sensors across the water network in large numbers, and the system that we've got in place that can cope with processing large amounts of metadata, which is what we'll be doing with ThingWorx, is ThingWorx. So that's going to be, again, identifying where devices don't work, so we can get the insights that we need from the devices and visit the ones that aren't working and get them working again. And so that's going to be tens to hundreds of thousands of devices. And then the other area where there's a lot coming is around condition-based maintenance. So fitting similar kinds of devices to the leakage devices. It's going to be devices listening to the sounds of the drives and the motors and the pumps, and providing that information off via a data streaming system similar to what we've got with the sewer level monitors to a third party who will have a look at that and provide us with insights back. So all of the stuff that we're talking about for smart networks basically comes into a classic control system, input, process, output, and that's what we've been trialing with what we're doing with ThingWorx with the sewer level monitors, and we've now got a pattern that we can scale across the whole of waste and water for all of these new IoT style innovations, where we've got, like I said right at the beginning, we used to have around about 8,000 outstations. Each one costs a significant amount of money to install, never mind for the electronics. And we're moving from that to £5,000 to £10,000 for an outstation to IoT devices that an expensive one is £500. So we're going from a few thousand outstations to hundreds of thousands of IoT devices, and we need a different level of technology to make sure that we're actually effectively gathering the data from that, so we can get the insights from it.
So this really is just the sort of tip of the iceberg, so to speak, right? I think there's a huge amount of other areas of value and different use cases across the entirety of the water network for both wastewater and water. So that's fantastic. I'll hand over to Leah back now to kick off the Q&A session.
So starting off with a question for Andrew, I think, from Kiel, who wants to know, how did Southern Water decide on the location and placement of those sensors that you've been talking about in order to maximise their value?
So we're just touching on that with Glyn. So the first one was, phase one was where we'd had historic pollutions, and that didn't turn out to be very useful. So phase two, it was where a pollution was more of an impact, would be more of an impact if we had one. And so phase two, we had four different use cases, and as we just described, it's been a much more effective way of doing it.
Great, thank you. And since introducing this, I think you've also actually touched on this one, but just to summarise, are you seeing more proactive versus reactive interventions?
Yes, yeah. The team who take the insights from Storm Harvester are called our proactive control team. So we've got three teams within the control center. The reactive control, who are our traditional, they deal with the alarms coming in from telemetry. Then there's a raid desk who deal with things that might cause an incident in the next 24 to 48 hours. And then the proactive control team. This is all proactive.
Great, thank you. And then Daniel was asking for some more information about the sensors that were deployed. And is there anything that you would like to detect with these sensors that you can't currently?
The vast majority of the sensors that we've got out there are pure radar. So all they're doing is measuring the level of the effluent. Some of them have got a device that hangs into the effluent and measures the temperature, but it also has a gravity sensor, so it can tell the flow. So we get an inference of flow and we get the temperature. That's really useful. It's probably more expensive for the device than the value we get from it right now, but it's been interesting to use it. One of the other things that we're looking at right now, one of the regulations that the EA are bringing towards us is measuring river water quality. So again, it's going to be tens of thousands of devices doing that. So we are looking at devices that measure turbidity, dissolved oxygen, ammonia. There's a handful of things that we're going to be picking up in rivers, and there's some trials going on with that. And again, those instruments will send their data back into a system that will be observed by ThingWorx. So yeah, there's a lot going on there. Oh, and the other one, this one's really interesting. Alongside the new trunk mains, we're laying optic fibers, not for communication, for picking up vibration. So there's a way you can again correlate the reflections coming back down the fiber to pick up any bursts in that main. We don't have that many new trunk mains going in, so that'll be small, but it'll need the kind of analytics that we get from ThingWorx.
Amazing, thank you. I think this one is maybe more in the vein still of believing that the sensors are sensing kind of what's in the water more than kind of flow level. So this might not be completely relevant to this call, but Dania has asked, in a continuous water quality monitoring sense, how do these sensors change things up at Southern Water?
But that comes back to what we'd be doing with the river water quality. So above and below every outfall, we'll be picking up water quality and using that to demonstrate whether it was agricultural runoff or if it was actually coming out of one of our outflows.
Great, thank you. Okay, and how has your project team actually been measuring the operational resilience that you're creating through this work?
Almost entirely by data availability.
Yeah.
So my team are more interested in data availability than anything else. We do some data quality, but it's almost entirely availability. Storm Harvester have got their own like pre-processing that they do before they do any analytics. So they're checking again for data quality. So they're checking our homework. But that my team is almost entirely focused on data availability. So the mean time to failure, mean time to recovery of the individual devices are the two metrics that we use, and then we mash those together to get availability.
Amazing, thank you. And how would the techniques used benefit from the ability to control and manipulate the flow at all parts of the sewer catchment, if there was a way to do that?
We are looking at that. So we've got a program, Smart Catchments. So it's a little bit different. Most of the sewer network is just gravity. So the effluent flows downhill, and it collects into a wet well, and then it's pumped up to another reservoir, another wet well, and then it flows down. Ultimately, after a few of those, into a treatment works. In Smart Catchments, we've got for example, 3 pumping stations leading into a treatment works. Each of those pumping stations can pass forward, say, I don't know, 10 cubic meters an hour. So we've got a capacity of 30 cubic meters an hour of effluent going into the treatment works. The treatment works can potentially only process 25 cubic meters an hour. So if all 3 pumps are all running at full capacity, we're going to cause a spill at the inflow of the treatment works. So we're looking at systems that can balance those 3 pumps in real time based on the rainfall across the whole catchment. So the catchment could be half a county. It'll be raining in part of the county, not in other parts of the county. So one of the 3 pumps needs to run at a different proportion to the other 2, dynamically based on rainfall. We catch the outcomes of the rainfall with the sewer level data, and then we could potentially use that. This is all new thinking. We're just in the process of putting the kit into the ground so we could use the insights that we get, but how we do that is all coming together right now. So we could use the data from the SLMs to massage how those pumps are creating the forward pass flow into the treatment works.
See, really interesting stuff. Thank you. And obviously you've touched a lot on kind of how transformational this trial's been and how what a massive benefit it's been to operations at Southern Water. How did you go about presenting the ROI to Southern Water kind of ahead of the trial, presenting the value case for this?
So this project started in 2020. I joined in 2023, so I wasn't around for that, but I've been through similar projects. So we have a big program where all of our large spends have to go through I mean, all the water companies will be the same. We have to go through a set of jump through a set of hoops to meet the requirements. So with the sewer level monitors, it was relatively straightforward. We were getting substantial fines, and the cost of the equipment went dramatically down around about 2020. The new devices came on the market that were substantially cheaper than anything that had been around before. So it became obvious that was the way to go. And so the ROI would have been based on the lower cost of this new instrumentation, and the increasing change in the regulatory regime and the fines going up, and the public perception going down. So
Yeah.
I haven't actually seen the original business case for this, but it'll be broadly based on that.
Yeah, in terms of investing in the technology specifically, I think specifically for this part of the project, right, to look at the SLM
Yes.
Devices, I think most of it went back to, Andrew said it himself earlier about this, the regulation was the sort of elephant in the room and making sure maximizing those availability rates, but then the knock-on effect of the kind of operational benefit and the cost of removing some of those subcontractors from the pool of subcontractors that were being worked with sort of made it a no-brainer to embark on this element of the project.
Mm-hmm.
Absolutely.
The contractors we were using in the past were going, like I said, we're going around on a time schedule, cleaning the sewers. We haven't increased the size of that team, but we've dramatically reduced the amount of pollution that we're causing.
Wow, that's amazing. That's really great. A couple more questions from the audience coming in. So Vincent wanted to ask, how much of an impact is network congestion having on your IoT devices? And is there a resilience plan in place for if that problem gets worse?
They generate surprisingly little data. In comparison to pretty much anything else, it's minuscule. We did a back of the fact packet calculation the other day. So our DCs, we've got two major DCs in the south of England, duty standby, and they've both got large pipes coming into them, internet connections coming into them that we run our VPNs over. The normal corporate traffic going into those DCs is like completely a different scale compared to the telemetry data.
See.
So if we get to tens of millions of devices, it might start to become a problem. We'll probably be in the cloud by then, so it probably won't be.
Yeah. Cool. Okay, thank you, Andrew. And then Lucas wanted to ask, how has Southern Water assessed the cyber and IT/OT risk of connected assets, and what are some of the measures to manage the risk?
The broad approach is along the lines of 62443. So we identify all of our assets, we identify the risks to those assets, and then we put mitigation plans in place for them all, and standard IT security. The IoT devices themselves don't touch our main telemetry network, what we call the OT network, the operational technology network. That's all SCADA and telemetry, traditional systems, and those systems have got much more compute capability in their networking infrastructure. So we run our VPN right out to the outstations. We don't do that with IoT. The IoT devices communicate with the vendor. So the first drop on any data coming in from these sewer level monitors is with one of the three vendors of those devices. They use their own security techniques to maintain data integrity across that part of the network. And then we've got VPN connections with them for platform-to-platform connections for the data coming in via MQTT. So that's how we secure the data transfer. How we risk assess it is 62443 and you know, standard IT security techniques above the OT security techniques.
Great, thank you so much. And obviously you weren't here at the beginning of, you know, rolling out the actual sensors themselves and whatnot, but when it came to actually implementing PTC and ThingWorx, were there any kind of risks that you identified early on, or was there any kind of challenges you came across while rolling out the ThingWorx technology that you've been able to mitigate? And is there any kind of best practice advice you'd be able to offer to the audience for kind of smooth delivery of something similar?
There was a risk assessment done of ThingWorx. Don't think we had to put any specific mitigations in place for ThingWorx in particular. I have not been directly, like you say, I wasn't around when that happened.
Yeah.
James, you were around at the time.
So sorry, repeat the question for me. I was just looking at another question which came through, which was seeing on it on the historian piece, and it caught me. So,
no, you're absolutely fine, don't worry. So when initially kind of rolling out this technology, did you and the project team at Southern kind of encounter or identify any potential risks, and how did you kind of mitigate those risks?
basically, when you're working with PTC, we do what's called like a value roadmap. So before any software can actually be sold to any of our customers, we have to go through quite a detailed process of consultancy, which was born out of Bain & Co, which is a process that we use internally. So from James Chandler, who's the CIO at the time, he actually put us in reached out to Gartner, and Gartner came to us. So we went through quite a vigorous process of trying to work through some use cases which were going to be brought up quite immediately. So from a risk perspective, there's nothing new which water companies are doing differently from what we do in manufacturing, if truth be told. It's just a different narrative on how they're verbalizing it. So from our perspective, we were quite comfortable in what we were going to do. So within about 5 months, we'd spun up the IoT environment and run through 2 of the use cases, and then from there, we expanded it out. So it was quite restricted, but no risks per se that I can think of at the top of my mind.
I think the Asset 360 element of the project, I think it goes back to what I said in the implementation journey. It's really about focusing in on the kind of core use cases. Let's not boil the ocean. Let's really focus our approach on specific use cases, and then build up from there. And I think that's what was really helpful was really laser focused on those, and then building up from the ground up. And that's helped mitigate risk. If we, there's a huge amount of different use cases that the system can cover, but if you try and tackle them all at once, it dilutes the focus, and you don't actually get to your end objective. So what was great working with Andrew and the team was diving into these very specific use cases, and then using them as the building blocks and the foundation for everything we did moving forward.
Yeah, absolutely. So kind of perfecting one thing before moving on to the other is a really key step. No, that's great. Thank you, Glyn. And we've had one more question in from Julian, who wanted to know, do you see this augmenting or replacing even traditional historian software in use at many water companies? I assume that's maybe one for Andrew.
That's been exercising a lot of people for the last 18 months, something like that. We've now effectively got, we use Pi from Aviva as our corporate historian. That's where all of the data ends up one way or another. And we've got, I'm forgetting the name of the database. There's a database that sits under ThingWorx that's basically got the same information. It's Influx. That's the one. Yeah. So we've now got our corporate historian is Pi, and then we've got InfluxDB with basically the same information in it. So there is a question as to, do we stick with Pi as our historian, or should we change over to Influx? At the minute, it could go either way.
Okay, great, thank you. And obviously, AI is quite a new phenomenon, and there can still be some kind of hesitations and worries when it comes to AI. Did you face any of those with your operational teams or kind of wider business teams at all when rolling this out, or was everyone kind of quite accepting, quite excited to give this a go?
Mhm. Yeah, there's two schools, aren't there? There's two camps in this one. There's a lot of people who are excited who think AI is going to save the world, and
Yep.
then a lot and others who are very, very skeptical about it.
Absolutely.
And then there's a third camp who are calling machine learning AI, and most of what we're doing is actually machine learning. We're not using a heck of a lot of AI here.
I
We've
see.
got models of how we expect the sewers to operate, and those are generated by creating models using historic data, rainfall
Yeah.
data, and what we've seen in the sewers. It's not really AI, not to my way of thinking. But people are looking at how we could potentially use AI in the whole estate. The piece that I was touching on earlier about smart networks, there's an element of AI that might come into that. We've got some good connections with Databricks, who are bringing a lot of discussions around where we might use AI. One of the
I might
things that,
Sorry,
well,
Andrew. I might just touch on that because I think people get easily confused between the difference on the machine learning and the AI piece quite easily because it's so now being pushed AI. But obviously,
Absolutely.
the machine learning piece is typically what's to identify the patterns in the data, so things like the anomaly detection and the predicting trends. But if you're looking at it from the AI piece, it's more the broader application of that. So, where those insights are then used to kind of support the decisions, so that's and really kind of prioritize the actions around it, so and that kind of automation of the workflow. So it's more of making sure that you're in a position to actually be AI ready. So I
Yeah.
think lots of companies will go, oh yeah, this is AI. It's not, it's actually machine learning. But ignorance is bliss, and it's more a case and play of how you're able to play it through. So when you're seeing the language piece, which on the little video you were seeing, that's more of a contextualized language-based AI model. But then how you're able to use the machine learning and making sure that you're AI ready is fundamentally the key point that we're trying to move companies towards. Hopefully
using
that bit. Yeah.
using LLMs to create those work orders is probably where we're going to go with
Yeah.
true AI. So our work orders are, we're using Maximo for that. So the work orders that get generated off the insights from Storm Harvester end up in Maximo in one way or another. And at the moment they're hand generated. So the proactive control team take the insights from Storm Harvester and they'll translate that over into a work order for one of the contractors. That could easily fall in with an LLM once we've got a little bit of data it can learn from.
Great, thank you. A couple more questions just to finish up on quickly. Someone was curious to see, would the introduction of digital twin capabilities potentially assist with this as well?
Yeah, so our Smart Networks program has got an element of digital twins involved in that. The smart catchments, again, the balancing the pumps into the forward pass flow on the treatment works. There's a lot that's being discussed there around how we would use digital twins to predict how it should work and then capture when it's not working as predicted. So identifying where it's not doing what we thought it should do. So yeah, there's a chunk around all of that. The digital twins around the sewer network, I'm a little bit skeptical right now because like I've said many times now, we've got enough sewer to go around the circumference of the globe.
Yeah.
Creating a digital twin of that with all the complexities against rainfall and the groundwater ingress and all of that, I don't know that we'll get there, but there's plenty of other places where digital twins are going to be transformatory.
Great, thank you. And was there any, just very quickly before we close, was there any kind of technical and data capabilities that you needed to already have in place at Southern Water before this kind of ThingWorx PTC solution was usable to you?
This was very much greenfield. We didn't have any sewer level. We did a little bit, but it was more around the EDMs. What we did with this was very much greenfield, and it was pulled together with data from GIS, but not a great deal else. So it's a brand new infrastructure.
Amazing, thank you. So obviously you needed to get the sensors in place to begin with, and it was kind of built from the ground up. So quite a few kind of capabilities that needed to get put into place before we were able to roll out ThingWorx. I'm sure we'll be able to touch on that in a bit more detail as part of the case study, about exactly kind of what was like an adoption checklist almost piece we tried to include in the case study. So whoever it was that asked that question, we will answer that in a little bit more detail in the case study. But now it is about time to wrap up the event today. So I just wanted to say a huge thank you to our presenters for such an insightful, open, honest slide deck today and presentation today. I really hope the audience found it as valuable as we did, and has lots of learnings to take away from today. We have just put that feedback poll into the chat again for anyone who would be able to leave us some feedback before you go today. That would be really, really appreciated. Any more questions for the presenters? We're also putting some contact details for PTC and some more information in the chat, so feel free to reach out to James or Glyn with any more questions. If you have any questions for Andrew or Southern Water, please do feel free to email those across to myself. That email will go in the chat as well in a second, and I can forward those on to the right teams at Southern to answer for you. As I say, we have recorded today's session, and we will be posting that alongside a written version of the case study and the slides from today's event. That should be available within the next week or so. So keep an eye on our LinkedIn, follow us on LinkedIn if you don't already, and that will be announced on there when that is available. Thank you so much to everybody who took out the time from their day to come today. We really hope you've enjoyed it and found it valuable. And thanks again to the presenters. I'll let you all get going. Have a lovely day.
Thanks all.
Thank you.
Thanks all.
Thanks everyone.
Bye.
Bye-bye.